So we're beginning to rapidly approach the end of the year. This is one of the last chapters. The next chapter that we're going to do is on probability, so it can almost seem like a bit of a diversion away from geometry, and it is. So this is really the last, like, truly geometric chapter, if you will, where it really sticks out as the one most applicable, or one of the ones most applicable to the real world. We're talking about the area of shapes. We're talking about the volume of three-dimensional figures. We're talking about shapes as they exist in space and how we measure them. All right. So what do I mean when I say area? When I say area, we're going to talk about 3D shapes later, but area, we're just talking about two-dimensional pieces, right? We're talking about how much space is contained within a polygon or a circle, if you will. All right. So we know the area of a circle. We just kind of went over circles. It is the area equals pi r squared. And what that's telling you is that within this circle, all this space, right? And I'm measuring it in two dimensions because I'm covering, right? I would measure something linearly as like, well, that's 4 inches. But once I start saying, this is 4 by 5, well, you don't say that there's 20 inches in here. You say it's 20 square inches because you're in the second dimension. You're talking about actual space. The area of a triangle we've discussed. 1/2 times base times height. So you can think of it as like half the height times the base. You can think of it as half the base times the height, or the base times the height divided by 2. The area of a square or rectangle is really, length times width, base times height, side by side, however you want to think about it. Squares are easy because all sides are the same, so it's just side times side. Talking about why this works, this is our parallelogram. The idea being that you can still just do base times height, and that it's really no different than a square or rectangle. It has everything to do with being able to basically take this piece off and put it right here, and it's automatically a rectangle now. And we'll walk through the proof of this in class. I think we might have already, honestly. I'm not going to include it in this video. For the most part, in general, this video is for you putting together your formula sheet, which you're going to use. In general, I don't really operate from the position of expecting you to memorize these formulas. We all have phones. The goal is not memorizing anything. The goal is, can you think critically and know when to use what formulas? That's really what I want you guys focusing on. So don't be overwhelmed like, gosh, I have to memorize all this. No, you should probably write it down and give yourself a reference sheet that you're going to use. All right. Area of a trapezoid. This one I know we did prove when we were in the quadrilaterals chapter. We're talking about trapezoids, but it's basically the average of the bases times the height. So base 1 plus base 2 over 2. The average base times the height. That's what gets you your area of a trapezoid. So what about other polygons? Specifically regular polygons. So specifically, the only other type, so the things I'm going to expect you to do are triangles, circles, squares, rectangles. Yes, trapezoids. Yes, parallelograms. And then if we expand beyond that, pentagons, hexagons, octagons, it's only going to be when they are regular shapes, which, as you remember, means all the sides are the same, all the interior angles are the same, and it's convex. Not that that matters too much. But anyways, so you can see here, okay, all the sides are the same. And the formula is area will always be 1/2. Here we have P. That's the perimeter, right? Times the apothem. Right? That's a term for going from the center of this regular polygon as an altitude here. Right? So why does this work? Why does this work? It works because we're just breaking it up into little triangles. So what you're saying is this. Look, here we have a hexagon. Using this apothem as the height of this triangle and this side B as the base, can I just say that what's happening here is I'm doing 1/2 times the base times the height times 6, because it's 6 of the exact same triangle area is what's contained within this hexagon, right? So 1/2 the base times height times the number of sides. And if you think about it, 6 times the base, well, 6 times the base, that's the perimeter. That's just going around this way. That's it. So honestly, I kind of prefer to think of it less as 1/2 the base times height and more of, 1/2 the perimeter times the height or the altitude apothem. I prefer to think of it mostly as the number of sides times 1/2 times base times height. Or sometimes instead of base, I'll do S for side. But I prefer it that way instead of simplifying it down to perimeter. And we're not even going to focus on these too much. Here's more discussion on that. And now we just jump right into examples, right? So here, what I'm expecting you to be able to do is recognize, well, if we've got an apothem of 10, or in this case, right, or this one, I think you'd have to do a little bit more work to figure out what that apothem is. Here they give it to you, 2.5, right? So we'd have to use the Pythagorean theorem to find out what this is. Then we'd have to double it. And I'd have to do 2 times whatever, using the Pythagorean theorem, this missing side is, times 2.5 times 1, 2, 3, 4, 5, 6, 7. Like I said, we are really not going to spend nearly as much time on these as we will anything else. They are interesting. But the goal when you're watching this video should really be that you're going through and making a reference sheet for yourself. Hey, if I see a regular polygon, I need to do this. If I see a trapezoid, I need to do this. And from there, go and work on the associated worksheet and check your answer key, the answer key that I make, and see how well you do. But that's it.